We are moving into section 1.5, properties of exponents today, and we are going to spend a couple of days on section 1.5. Today talking about properties of exponents. Tomorrow we'll talk about scientific notation. So when the base includes more than one symbol, it is written in parentheses. So I made this chart here to kind of show you what parentheses do and how they can change your answer. We have the same -2x and exponent of 3 here, but then we have parentheses in different spots to kind of show you what it would look like in expanded form and how different it is depending on where those exponents are, where those parentheses are. So the first one, -2x to the third power without exponents, the only thing being raised to the exponent is an x. So that -2 is out front being multiplied by x times x times x because we have exponent of 3, which means 3 of those. Then we have negative sign out front, which is like a -1 being multiplied out there. And then 2x inside of the parentheses raised to the third power. So what that means is 2x is our base, and that is getting raised to the third power. So we have our negative sign. When we write an expanded form, we have to remember to put that out there. But then we have 2x times 2x times 2x because all of that is being raised to the third power. And then we have everything inside of parentheses with the exponent of 3. So our base that's being raised to the third power is -2x. So then we would have 3 -2x's being multiplied together. So really have to pay attention and watch out where exponents are and what we need to do with those. Write each expression in expanded form. So our first one, 4y to the third power, and 4y is in parentheses and the exponent's outside. So that means that 4y is being multiplied or being raised to the exponent of 3, not just the y. So in expanded form, this just means we would have 3 of those 4y's. This one, -a to the second power, that negative sign out front without parentheses is just like a -1. So we don't write the 1, we just write the negative sign. And then a to the second power would be a times a. Next we have 2y squared, and then x minus 3 in parentheses raised to the third power. So we have two different things being raised to exponents here, so we have to expand both of them. So we have that 2 out front, and then we have y squared, and y squared just means y times y. Then we have x minus 3 in parentheses. We have 3 of the x minus 3's, so we have to write x minus 3, x minus 3, and x minus 3. And that's being multiplied as well there. Next are a couple of properties. The first one is zero exponent property. Just simply says anything to the zero exponent is 1. So as long as it's not 0 to the 0 power, because you can't do that, your answer is going to be 1. So examples, I have 125 to the 0 power, that's 1. K to the 0 power, that's 1. Anytime you see that, you can simplify it down to 1 automatically. Next is negative exponent property. A non-zero base raised to a negative exponent is equal to the reciprocal of the base raised to the opposite positive exponent. So for an example here, I have 7 to the -2nd power. And if you think about 7 as a fraction, we would just put a 1 under it, and then you take the reciprocal of that. So you flip it over and you have 1/7, and once you flip it, that makes the exponent positive. And then you distribute that 2 to both the numerator and the denominator. So 1 squared is 1, and 7 squared would be 49. Then if you start off with a fraction, you simply just flip that fraction or find its reciprocal. So 3/2 becomes 2/3, and then the -3rd exponent becomes a +3, and you distribute that 3 to both the numerator and the denominator, and 2 to the 3rd power is 8, and 3 to the 3rd power is 27. So a couple of examples here. We're going to have to simplify 2 to the -3rd power. So make that a fraction. Then you have to flip it. And once you flip it, the exponent becomes positive. And then distribute that 3. So you have 1 to the 3rd power would be 1. And 2 to the 3rd power would be 8. So your final answer of 2 to the -3rd is equal to 1/8. Then if you are given a fraction with a negative sign out front, so we got to be very careful there. We have to remember to always carry that negative sign with us. So we're going to flip that fraction, and it becomes 4/3. And then our exponent of -4 becomes positive. So now we have 4 to the 4th power at the top, which will be 256. And at the bottom, we have 3 to the 4th power, which is 81. And we have to bring that negative sign over. And then if we wanted to simplify that, we would have -3 and 13 over 81 for our final answer. Then we're going to review the properties of exponents that we learned back in Algebra 1. The first one is product of powers, and that means if you have the same base, you're going to add your exponents. So for my example, I have x to the 3rd times x to the 4th. The base is x in both of them, and we're being multiplied together, so we can add the exponent. Quotient of powers property says that if we have division with the same base, we can subtract our exponents. So 3 to the 7th divided by 3 to the 2nd, 7 minus 2 is 5, so our exponent becomes 5. Power of a power property means we're going to multiply our exponents. That would look like something raised to an exponent inside of parentheses, and then that raised to another exponent outside. So you're just going to multiply those two exponents. And then power of a product property, you're going to have to distribute. That is where you have something being multiplied together inside of parentheses and all of it being raised to the exponent. So in my example here, we would have to distribute that 3 to the 2 and the x, and then simplify 2 to the 3rd down to 8. So it would simplify down to 8x to the 3rd. And then the power of a quotient property is similar, except for you have division inside of the parenthesis. You still have to distribute that exponent. So 3 to the 5th, or 3/5 raised to the 2nd power. That 2 goes to the 3 and the 5, so you'd have 3 squared over 5 squared, which would simplify down to 9 over 25. And now we're going to use those rules to simplify each expression. And looking at this example, it's all multiplication. So if you thought about it all split up like this, that's exactly what it says up there. We could multiply together the 2 and the -5, so that would give us -10. And then the x to the 3rd times x, x doesn't have an exponent, so when you have a variable without an exponent, you always just, it's always just a 1. There's only one of those. So that's multiplication. The bases are x's in both, so we can add our exponents, so that becomes x to the 4th, and that is our simplified version. Over here, we have a quotient inside of parentheses being raised to an exponent, so we have to distribute that 2 to everything inside. So a to the 2nd power, we don't have to do anything fancy with, but we have b to the 4th power, and then that's being raised to the 2nd power. So that's where we have to multiply those exponents when you have 2 of them like that. So that becomes b to the 8th. And then at the bottom, we already have b to the 7th, and that's being raised to the 2nd power. So again, we're going to have to multiply. So that would become b to the 14th. Now, when you're simplifying, you can't have the same letters in there multiple times, so we need to simplify that b to the 8th over b to the 14th down. So we're going to leave the a squared because there's nothing to simplify it with, but we have division, so that rule said that we would subtract our exponents, so 8 minus 14 would give me a -6. Again, when we're simplifying, we cannot have a negative exponent, so we're going to pretend this is a fraction. And what happens is, since that a to the 2nd power doesn't have a negative exponent, only this b to the -6 does, we're only going to move b to the -6. And when we have a fraction, to make that positive, we just move it to the opposite spot in the fraction. So this one's in the numerator, we're going to move it to the denominator, and its exponent becomes positive. So we have a squared over b to the 6th for our final simplified answer.